So I'm going to guess the majority of you have not heard of Arthrex before, so just start off with a little bit of information about us. We are the worldwide leader in arthroscopic and sports medicine surgical devices. We work very closely with, I think a lot of you probably watch the Super Bowl and watch NFL teams, NBA teams, and all playing. Arthrex works very closely with a lot of those players, especially ones that sustain critical injuries and want to recover quickly, have minimally invasive surgery to come back. So I'm not going to name drop any, but a lot of people you've seen have used Arthrex products. They just don't display it on their apparel like Nike does. We have over 6,000 products for arthroscopic and other surgical procedures, and we introduce over 500 new products every year. We've been in business since 1984. We are privately held. We're right now slightly over $1 billion annually in revenue, and we've had double-digit growth in revenue for over the last 5 years. So it's definitely been a growing company and a success story, really, in Florida. We have over 1,500 direct employees, and we've been adding about 150 employees a year. Just to talk a little bit about our product development teams. They really range in several areas. There's knee and hip, upper extremities, DEX, which is what we call digital extremities, imaging and resection, and finally biologics. If you want any other information about Arthrex, if you've got an ACL problem or a shoulder or something and you're thinking maybe your doctor hasn't told you everything you need to know, you're welcome to go to our website and to Ortho Illustrated, which it's really a patient portal for people to learn a lot more about some of the medical procedures. So with that little advertisement, let me get into the real heart of our discussion here. About a year and a half ago, Arthrex started a process of investigating a manufacturing execution system. Really, there were a few different reasons for that. The biggest one was growth. We had built ourselves up on manual systems, which worked well. However, they had put a lot of strain on our environment. We were throwing more people, more machines at our manufacturing processes, but as the growth continued to increase, it's become very difficult for us to have all the visibility and be able to have the agility as an organization for our day-to-day operations. It also factors hand in hand with opportunity and efficiency. We saw we were definitely at a point where our lack of a stronger execution system was keeping us from being able to make educated decisions. It's not that we have no computer systems around, it's just that things were not all connected together to where we were able to make real-time decisions. And you saw we were releasing 6,000, we have over 6,000 products and 500 plus a year. What that means is there's a lot of decisions that are happening every single day in terms of products that need to be moved up in priority, moved down in priority, decisions that need to be made from a manufacturing side, and it's become more and more difficult as we have literally hundreds of thousands of lots running in a given month. There's also a cost benefit for us. Our manufacturing cycle time is around, it's over 30 days. We can reduce that cycle time through some more efficient use of our systems. There's also an inventory level that goes hand in hand with that. So we were looking at a manufacturing system as really helping us with supporting the growth, bringing us more visibility, but also having a real impact on our cost. Which really brings us to what was the MES system we wanted to do. Well, first of all, we do discrete manufacturing. We wanted to really focus everything on our final, start at the final production and then migrate upstream through our processes. We have a paper record. As a medical device company, our systems have to be validated in order to be a system of record. What that means is FDA comes in and says, if anytime they want to come and take a look at what we're doing, they want to have proof that every single manufacturing lot was fully signed off correctly, everything was done appropriately, and if your systems have not been validated, they will rely on a paper record. So right now we have reams and reams of paper that support all of our processes. When I say reams and reams, we generate over 2 million sheets of paper a year in our device history record. It's not an unusual number for any of you that work in medical devices. That is the reality if you don't have a validated system. A lot of this centered for us, we made a decision, we looked at several systems. Oracle had a comprehensive solution, and part of that centered around quality collection plans. Things like process monitoring, inspection data, lot status, and also being able to have the links to our legacy data as well. We also, when it got down to the real heart of this discussion, which is EMI, we needed to be able to monitor our process, be able to have the visibility on anything going on real time, and beyond that, scheduling. Because we were doing all of our manufacturing processes manually, our production scheduling was more or less a manual process as well. Although we have a finite scheduling system, we more or less took the schedule it came with a grain of salt, and then the supervisors on the shop floor effectively are making the real scheduling decisions versus truly being able to schedule everything up front. That's really because things change so quickly on our shop floor that a scheduling system that doesn't have full information on everything that's going on, including downtime, operator availability and such, really can't make educated decisions in real time. So, when it boils down to it, we had an Oracle implementation which started out with discrete manufacturing and shop floor, then a product called MOC, which is their Manufacturing Operations Center. This is really at the heart of EMI for our organization because MOC provides all the business intelligence coming out of our MES system, as well as coming directly out of our production machines. There was also the production scheduling piece, and finally, one other very important piece for us was Agile, which is a PLM system, which also supports all of our engineering change management and all. So when we talk about going paperless, there's really two key pieces of paper that are in our process. There's a device history record and a device master record. The device history record and all are being supported by the MES system. The device master record is supported by the Agile PLM system. So by validating this entire suite, we can go completely paperless. So I just talked a little bit about Agile PLM here. It does provide all of the engineering content in our system. It consolidates legacy data, all of the change control, change management, and it's the electronic device record. It's also integrated directly to our manufacturing processes, so we can control our items, control our BOMs through it, and we can deliver all of our production methods, our manufacturing specs, and also any other machine files, which include things like our Predator system, which is how we load machine instructions real time. That loading will all be initiated out of Agile as its scheduling processes. So that way, our machines on the shop floor are loaded with machine instructions prior to the lot getting started, and we can save time in that way. And certainly the change control process, that's critical to Agile. It's part of being able to handle all of our ECOs. MOC, which I put here planned use because we're not officially live yet until our system is validated. We went live in an unvalidated state at the latter part of last year. We are currently working on the validation pieces. So everything here is planned until we officially are validated, in which case we no longer need to run in parallel, and this becomes our system of record. MOC gives us our real-time visibility. It has the dashboards. What's very important is the drill-down capability, which for us means it's one thing to see a bunch of really pretty gauges and seeing, okay, that's red, that's green, and this looks good, that doesn't look good. For us, it's much more important for someone at a shop floor supervisory level, as well as from an overall operations management level, to be able to really drill down on the data real time and maybe make some decisions prior to letting it go so far out of schedule that it creates a real problem. It gives us a lot of agility. One of the things that happens for us is, and it's a little bit unique for us, is we could at any given time be given a hot order because there's an actual surgery that's going to happen and somebody needs something badly. And when that happens, we will interrupt any lot that's in progress and go ahead and insert something in. This doesn't happen daily, but it does happen probably at least a couple of times a month. And so this allows us to be able to do that immediately in the system rather than outside the system, which is how we do it now. There are OEE metrics, which I know Janice touched upon as well earlier. And lastly, and very importantly, is the integration with our PLCs and CNC machines. We have over 100 PLCs and CNC machines scattered throughout our shop floor. And for us, it's very important to get real-time information from them. They have the capability of recording everything from scrap information to how many lots are run to just a simple MI up or an MI down. Right now, that information is not being conveyed directly to a system. That's what MOC allows us to have. So by feeding that data through MOC and also to our MES system, we have real-time information that tells us are our cycle times what we've put in our finite scheduling system, or do they need to be adjusted in real time? Do we have machines down or operators down that we thought were going to be available, and can we reshuffle the shop floor based on that? Just to give you a little bit of what those screenshots look like from MOC, this is a screenshot of our machine availability. What you can see here is that we're showing 4 different machines, and 3 of them are showing availability. But basically, it's actually this particular one is more or less an up or down, because your machine is either available or it's not available. So this shows one of our machines being down in that particular pool. This is a trend list here, so we can study the trends of particular machines. What often happens is we may buy new generations of machines or go to a different vendor for a new spec. Having a trend of how a machine runs tells us a couple of things. One is there a relationship between the operators assigned to the machine and the machine themselves? And or is it that a certain generation of the machine needs an upgrade? Or is there some other decision we need to be making based on the overall trend? The trend is not just the throughput, it's also how much downtime are you having from a longer term standpoint. And finally, there's production loss and capacity. This is just another representation here. You really can't read the different reason codes in there, but it really allows us, if we drill down to any of those, we can see the actual lots that contributed to any of those. So finally, we're at the cusp of success here, and we also, I was asked to talk a little bit about lessons learned up to this point. Well, the biggest one really boiled down to integration and data migration. What we found was that the interfaces, while we bought a solution that's pretty comprehensive, and we still have some legacy systems in the background still that still have to work. We have something called gauge track, which measures the which runs off the gauges. We have several other smaller systems like that. The interfaces, no matter what you may hear, they don't work out of the box. So you do need to do some configuration on them. They tend to be needing more configuration the more information you want to get out of them. And for us, we wanted to get a lot of information, so there was a lot of configuration required. There's also sometimes more stringent requirements of a new system, which may require data cleansing. For us specifically, that had a lot to do with Agile. Agile is a world-class PLM system, which is used by a lot of med device companies. However, because it's much more strict about the kind of data you put into it, we couldn't just export data from our legacy system and it worked directly into the new system. And there weren't really the easiest tools in place to move those. A lot of it really required a lot of human intervention to make a decision on what is the right, destination for this data. Data migration ended up being a very long pole in our tent. Finally, the CNCs and PLCs we talked about, we made a decision. We wanted to connect every single piece of equipment. And we started off with CNCs and PLCs. We're going to be moving on to other environmental and temperature and humidity controls as well. But the one thing we learned very early on was that is an area that there's really no standardization. It's not even standardized within a particular machine manufacturer, much less if you're buying machines across several manufacturers. It's difficult to obtain the machine codes, and there really isn't a very simple way of getting that information out. As we learned more about it, we became experts ourselves, and we found that once you've learned, at least across a broader suite of machines, each succeeding machine is not as hard to do, and we've now spec'd out how we want any new purchasing decisions to be made as far as the type of connectivity we asked for. None of that was a thought when these machines were originally purchased, some of them over 10 years ago. Connectivity to an MOC or an MES system was not even in the thoughts at the time. So some decisions made then, we paid for them now. And the last one is really a bullet that's specific to those in pharmaceutical, med device, and similar regulated industries. Validation has had a large impact on our project timeline, just because for us, we can't just validate one piece of a process. We have to validate the end-to-end process. So that for us meant we couldn't necessarily just go live on one small piece that we were ready for and start gaining the value. We needed to build upon everything and then submit the entire end-to-end process for validation in order to move things over to a true paperless system. And as far as business transformation, a lot of this really started. It really started with engaging the employees. It's one thing for an executive team to support the vision and say, this is something we want to do as an organization. We're a world-class organization. We want a world-class MES system. The first concern you have when you start talking about employees is, are they worried that automation means losing jobs? And so a lot of this was really very early on. We engaged the employees. We wanted them to realize that this really was about making everybody more efficient. One thing that we have going for us is that the growth has continued throughout this project. We started the actual implementation about a year ago, and we've even had one of our largest growth years over the last 12 months. So that's really quelled a lot of the concerns that, if you're going to make my MES system that much more efficient, you're going to need less operators. Well, what it really has done for us is it means we can do more throughput and we can keep the operators, but some of them are being moved into other areas that we have other need. We also did a lot of resource commitments up front. An implementation like this is very difficult to do by just bringing in a consulting team and having them implement it with just a couple of people assigned to it. We ended up bringing in a large team of people to replace day-to-day jobs and free up people so that they could work full-time on this implementation. We also had a lot of open discussion forums. We wanted to share information with the employees, do open Q&As, just like a forum like this, and that really turned out to be very positive, I think, for everybody. It ended up turning from something that people had a lot of questions to one where really the whole company is excited about and sees the value of it, and is seeing it turn around a lot of things on the shop floor even before the actual go live. There's a lot of formalized training that was also involved, and I think by having that training, it allowed people to also feel more empowered, because why would we be training all of the users? Why would we be training all of the project team and all if we were not going to be keeping them along in the long term? So in terms of being able to handle the change management and all, that had a large part of it. And lastly, we did a lot of branding and internal marketing of the project. Our founder spoke greatly about it as well. We started talking about it even when we brought physicians and our other customers around. We explained what we were doing when we brought them. It was a sense of pride for a lot of people, because we were able to start, even though we weren't able to use it as a system of record, we can start turning on some of the functionality, including some of the data, and show it to people as they come around. And it's interesting, and it also shows just how much work is going on real time at any given time on the shop floor. And so it's really been embraced, and really the big thing we're waiting on right now is completing the validation so we can really enjoy taking all of those reams of paper and taking them out of the shop floor. In conclusion, we started this process really, and I know the talk is really focused on the EMI aspect, but this was really a complete MES implementation for us, where EMI played a very significant role. And as we've gotten into this project and learned more, we've continued to find more reasons why EMI is very important to us. We're starting to collect data that we didn't even plan to collect when we started getting into the project, and we've already started making business decisions ahead of that. We're looking forward a lot to where we can turn it on for every single machine out there, but even with the 24 pools that are currently connected, we are getting some very important information, and it's helped us make buying decisions on new machines going forward. So it's been exciting for us, and we really look forward to what we can do with the data as we go fully live this year. So anyway, with that said, thank you, and I'll turn it back over. I think I figured out how to use this.